So in this question we have to perform heap sort. For this question we will first try to build a heap using the array. So how do we build the heap? Okay, so firstly we make three functions which extract parent, left child and right child. So we have like private int parent of node I, like let's suppose index I, we get is like return for node for any node with I, for its parent we get I minus 1 by 2. Similarly we can get for left node and right node. So we have private int left child left child is always present at like 2I plus 1. Okay. And right child is present at 2I plus 2. Now to build a heap, we will we want elements elements at some parent position to satisfy heap conditions. Okay, so to satisfy heap conditions, so we will build max heap. Okay, so we want this to satisfy some heap condition. Satisfy max heap condition, which say so for that we will, what is the element at the parent position, smallest element at parent position? That will be like the parent of n minus 1. Okay, so we'll look at this. It is at some parent position, and now till like I is like greater than 0, because okay, I is greater than equal to 0, but like yeah, I is greater than equal to 0, we will, this node also has to satisfy the max heap condition, and now we do minus. Okay, for all these nodes we want to heapify the array, the n, and then the ith node. Okay, for this array node, okay, to maintain the heap property. So for the max heap, so we need to have the largest. Okay, so let's call it largest index because to I. Let's suppose like I is large. So for the max heap, okay, and we can like similarly have int left is equals to left. Okay, so what I want to say is like for maintain the max heap property, for it like we have this like parent should be greater than the child. Okay, parent should be greater than the child. So we need the parent, that's this node, like for every parent. Okay, for every parent we are doing this. So for every parent it should be greater than the child. We have this int child int, like let's go left. Okay, so left index, and we can get left index simply by calling like left child on I. Okay, and then we have this integer right index, which is also like simply calling right child of I, which are none other than 2i plus 1 and 2i plus 2. Okay, Now we get largest index, left child, and right child. Now we need to see if largest index changes. Okay, so if the array of largest index is actually smaller than the array of the left index. Okay, and we need to also have another thing okay, so I'm going to check if left child is less than n. Okay, so it has to be in the heap at least. Okay. So if we found a new left child, so what we do is we have the largest index as left left index. So this is the largest index. Now similarly we do it for the right one. Okay. Now if the right child is less than n and array of the largest index is less than right index, array of right index and largest index is equals to our right index. Okay, now we got the largest index. Now if the largest index has changed, now if largest index is not equals to I, if the largest index has changed, what we will do is we will swap largest index in I. Okay, so in order to do that, what we can have is we can have int temp is equals to array of I, and then array of I is array of largest index, and then array of largest index is equals to basically temp. So we have swapped largest index and I, and now we have greater than child. Now we go from top to bottom. We go from top to bottom. Okay. We go from top to bottom and place the parent in the position where it can stay, or where it does not break any heap rules. Okay, so any max heap rules. Okay, now we have this we have changed it. Okay, we have changed it, but our temp or original parent might be still breaking rules. So what we need to do is we need to heapify the array of length n, and our index right now is our largest index. Now we have written functions of build heap and heapify. Now we need to do the heap sort. Okay, in order to do the heap sort, what we will do to perform the heap sort function? Firstly, we will build the heap. Okay, firstly we will build heap. Okay, this array needs to actually satisfy the heap functions. Okay, array needs to satisfy heap functions. Okay, so every parent is now after this function, the basically the like the smallest parent, you can say, is at its correct position. Okay, it's like, so now if you look at this, so like if we have this heap of 5, so n minus 1 will be 4, which is basically I'm referring to this index node. So for its parent will be like 4 minus 1 by 2. That's basically 4 minus 1 is 3. 3 by 2 is 1. So it's like 0, 1. Okay. It's 0, 1, 2, 3, 4. So we got its parent. So this is my first parent. So how will this like build heap work? It will look at this and then it will go at 0 thing. So firstly we will heapify this. So after heapifying like this element, okay, and we are just doing this. So after heapifying this element, this whole thing will be following heap rules. Okay, now we will look at this function. Okay, now we will go at this. So this whole thing is left child is following heap function, its right child is also following heap functions. It's very easy to heapify. We can just do this, and instead if we go from here and here, then it won't work, because like this element is not like the left child of the 0th parent is not heapified yet if we start by the root node itself. Okay, that's why we go from like the first, like the basically the smallest parent with the largest parent. Okay, and yeah, we build the heap, we heapify, and now we need to sort it. So for that we just build the heap. Okay, first of all we build the heap. Okay, now the heap is built. Now what we need to do is like after the heap is filled, after the max heap is filled, okay, in the max heap, the largest element is always the root. Okay, is always the root. So we know the largest element. We need to put this largest element at the back of the array. Okay, so what we do is like, so we swap. So we basically so in this array we swap the root, that's the largest element, and the last element, or n-1 indexed element. Okay, so what we do is like this. Okay, and so what we do is like integer temp is equals to array 0, and now we have this like now we have this array of n-1 is equals to array of 0 is equals to this, like now this will have this n-1 element, and the array of n-1 will be basically temp. Okay, and now we can heap it. Now if we exclude the last element, okay, if we exclude the last element, or heap size, like our new array size is equals to n-1. Okay, a new array size is equals to n-1, and here the root element does not follow heap rules. Okay, so we will heapify it. Okay, so we'll heapify the root element. So how do we do it? We do it array. Okay, we tell the size and then we heapify the root element. Okay, now we repeat these steps for the new heap. For this new heap. Okay, so yeah, so how to do this? Okay, so what I'm gonna do is like making a for loop. Okay, so for we go from all elements. Okay, we go from the last element in -1. Okay, and we go all elements. It's like I is greater than or equals to 0. Go to all elements, and what we do is like we have this last element. Okay, so we have this in temp is equals to array of 0, and array of 0 is basically the last element of, like, basically the top element of this, which is basically array of I. Okay, and now array of I will be equals to our temp. Okay, so we swap arrays first element with the end. Arrays first element, or you can say first, or you can say largest element with the end. Okay, and you can say like, what does I indicate? I is equals to index, last index for our new, for our heap or array. Okay, now we have this. Okay, and we like it keeps changing, and now like in order to for the rest of the heap, the rest of the array, like that's indexed 0 to n minus 2, 0 to I minus 1, it should follow heap, max heap rules. Okay, for that we do heapify. Now we have array, but now our size is like I minus 1, and we need to heapify the top element because that's what we changed. Okay, and now we do this simply. Okay, and we'll just comment this out, like multi-line comment. Okay, and this we build this. Okay, so we did some mistakes actually, so I'm gonna have this like if right index and similarly mark left index. Okay, so yes, it has to be actually I minus minus. So I found the error. It's actually in this I minus 1 because like this is the size. Okay, so for the rest of the index, for the rest of the array index 0 to I minus 1, you should follow the max heap rules. The size of new like array now will be equal to, basically you can say I minus 1, okay, minus 0 plus 1. Okay, like that, which is basically a I. Okay, so the size will be I and not that. Hey, I got additional geek bits. Thanks and bye.